Let's look at a function. Let's say x comma y equal to x plus 3y. Okay. Now what I do is I multiply both x and y by the same argument. So let us say px comma py. So that means x value is px. So I write px. Y value is py. So I write py. Now I simplify it. So what happens? P is common. So I take out p and I'm left with p times x plus 3y. Now x plus 3y is nothing but f of x comma y. Now remember, here p is to the power of 1. Now if a function can be transformed into this form, then it is called a homogeneous function. And depending on what the exponent is of p, exponent of p is called the degree of the function. Yes, let's look at some additional examples. Let's say f of x comma y is equal to 4x square plus y square. Okay, let's say px comma py. Remember, instead of p we can use any number as well. Is equal to 4. Remember, x is going to be substituted by px square plus py square. Again, simplifying it, we get 4p square x square plus p square y square. Let's take out common, which is p square. We are left with 4x square plus y square. Okay, and this can be written as 4x square plus y square is nothing but f of x comma y. So this can be written as f of x comma y. So which means here it is p square. So here the degree is 2 and it is a homogeneous function. Okay, let's take another example. F of x comma y is equal to x cube plus y square. This is slightly different because till now, if you notice that this was x to the power of 1, y to the power of 1. So degree of both the terms was same. Here also the degree of both the terms was same. But here the degree is different. Here it is x cube, whereas it is y square. Now let's see whether this also is a homogeneous function or not. So what do? F of px comma py is equal to px cube plus py cube square, which is equal to p cube x cube plus p square y square. So what's common? P square is common and we are left with px cube plus y square. This is not equal to p square f of x comma y, because here one p additional has come. So it is not a homogeneous function. Okay, let's look at another example. Let's say f of x comma y is equal to x cube plus y cube by x plus y. Now here what happens? Again, let's say px comma py is equal to px cube plus py cube by px plus py. So again, p cube x cube plus p cube y cube divided by p times x plus y. And here take out what is common, p cube x cube plus y cube divided by p times x plus y, which is, if we remove this, this becomes square. So we can rewrite this as p square, and this is nothing but f of x comma y. So again, this is a homogeneous function with order with degree 2. Okay, now these were all polynomial functions. Now let's look at something which is not polynomial. Let's say f of x comma y is equal to x cos y by x, right? Again, f of px, see, basically what we are doing is multiplying the arguments x and y with the same factor. Okay, so now what happens, wherever x is there we substitute px, wherever it is y we substitute py. So px cos py by px, p and p gets cancelled and we are left with px cos y by x, which can be written as p to the power of 1 x cos y by x is nothing but f of x comma y. So which means again it is a homogeneous function with degree 1. Let's look at another one similar to the previous one. Say f of x comma y equal to cos x cube plus y cube by x plus y. So f of px comma py would be what? Cos p cube x cube plus p cube y cube by px plus py. Again simplifying, p cube x cube plus y cube divided by p x plus y. This is equal to cos p square, and this can be written as f of x comma y. Now the problem is this is not equal to cos x cube plus y cube by x plus y, because p square is inside. The p square should come out. If p square is able to come out, then only it will be equal, and it can't. So that's why it's unequal and it is not homogeneous. Okay. A homogeneous polynomial is a polynomial made up of a sum of monomials of the same degree. Just as an example, let's take x to the power of 7 plus anything 5, x to the power of 5, y to the power of 2 plus 10 x y to the power of 6. So here the degree of this is 7, degree of this is 7, and degree of this is 7. So it is a homogeneous function of degree 7. Polynomial homogeneous functions. We say x comma z y is equal to z to the power of n f of x comma y. Then it is a polynomial, homogeneous function. If this polynomial can be written in this form of degree n. Okay. Another way in which we can look at this homogeneous functions is if we can rewrite f of x comma y in this form. Say x to the power of n. Yes. And p of y by x. If we can write it in this form also, it is a homogeneous function. Let's take a example. Say f of x comma y is equal to x to the power of 4 minus y to the power of 4 by x plus y. This can be rewritten as x to the power of 4, we take it out. So if we take it out, what happens? Here we are left with 1 minus y to the power of 4 by x to the power of 4. And in the denominator, we take out x. and we are left with 1 plus y by x. So 1 x gets cancelled, so x cube, and we can rewrite this as 1 minus by x to the power of 4 by 1 plus y by x, and this we can say that this is a function of y by x. Yes, so which means this is a homogeneous function of degree 3. Okay, I think you got the idea. Bye for now.